going to start with an introduction to HTTP. All right, so just going to talk about HTTP today. So HTTP is the Huawei desktop protocol. So the Huawei desktop protocol is what we're going to talk about. Today. So the Huawei desktop protocol is just Huawei next generation cloud access and remote desktop protocol, which is designed to just deliver a high performance, secure, and high performance virtual desktop experience. So it's just a cloud access, or if we can say a remote desktop protocol, which is just designed for virtual desktop experience. So you basically have a virtual computer out there. So we have up to 64 virtual channels in the HTTP. The HTTP those are certain key capabilities and advantages of using HTTP is that it's a multi-channel communication. It has multi-channel communication, which means it can support up to 64 virtual channels, and each channel will carry its own data. Example, your keyboards, mouse, video, or audio. So it also, one of the advantages that it also has what we will call a QoS prioritization, which means that it ensures critical inputs such as your keyboard, your mouse, that will remain faster and responsive, so which will improve the user experience and the security as well. So you also have another capability of an intelligent rendering, which means that it's going to choose the server side and the local side, depending on the content. Okay, so you have your high fidelity audio, you have clear video playback, which means that we have the video hardware acceleration, which will ensure that we have a smooth playback, and it's going to support like 4K videos with stable performance. And we also have a very good low-latency compression algorithm, which means that the compression is optimized. So we have different compression algorithm applied per application type. So the low-latency compression for user interface element like text, your icon, and office applications. So this will ensure that we have a good visual if we have things that involve like motions and that. So we have a perfect clarity with that. Okay, so and then in terms of the audio, we have high fidelity audio, which means that you have smart voice detection, real-time noise reduction. You have also what we call transparent channel for terminal devices. So we basically have clear and natural audio experience while using this platform. And in terms of the protocols that it used, we have a very strong protocol management policies, which means it's secure and flexible, right? So this secure and flexible protocol management will support customization per user groups. Okay, so we have multiple policies controlling like the channel access, the communication flow, the security and management. So this will ensure that the data transmission is completely safe. So why using HTTP? Because of its features. So we have up to 64 channels in terms of our channel, because this is going to help the system to have a high performance and high responsiveness as well. So we have hardware accelerated multimedia. That means that we have the benefit of having smooth 4K videos playback. All right. So we've mentioned the other. So for you to understand where is HDP really used, HDP is used in cloud desktop such as Huawei Fusion, which we've spoken about in previous chapters. It's used in Huawei Cloud Workspace. You can use it in corporate office virtualization, call centers, or any type of company where we have multimedia operation, right? Or if you want to do things such as mobile or remote workforce and working from a different place, you know. So you have a company where there's people working from home, they can access the resources of the company. So that's when you will need to use the HTTP, which is the Huawei Desktop Protocol. So you're basically using a virtual desktop from a distance. All right. So we have common desktop protocols that we're going to go through on this. Okay, so with the architecture of HTTP, as we've mentioned that already, so we have different operating systems that are used on the server side as well. We have many features that comes in the architecture, and this comes with common desktop protocol. We have certain protocols such as the ICA, HDX. So when we talk about the HCA, this is one of the ICA is one of the common desktop protocol of HTTP. So the ICA is what we call an independent computing architecture, right? Or again, we also call it the Citrix ICA. So the Citrix ICA, which is the Citrix Independent Computing architecture, right? This is one of the most popular virtual desktop protocol, right? So which will support a wide range of mobile terminal. So the Citrix ICA is one of the most widely adopted virtual desktop and application protocol, right? It's going to allow you with remote users to access applications and desktop hosted on data center servers with high efficiency and really rich functionalities. So and then we also have the HDX. One second, guys. Let me just check something. Give me a second. All right. Sorry about that, guys. All right. So we have, and again, we have this ICA, which is going to be, which is going to support certain servers such as the Xen server, the vSphere. Yeah. So this is one of the most popular virtual desktop protocol used. And then we also have the high definition experience, which is the HDX. So when we talk about high definition experience, this is just an enhanced version of the ICA, which means the HDX will introduce things like advanced multimedia graphics and collaboration capabilities to just improve the user experience. So some key features of the ICA is just that that feature of the broad device support, which means that it works on a large range of terminals and mobile devices. In terms of network protocol, it can support your your TCP IP in terms of it can support your NetBIOS, IPX, SPX, and then we have a multi-hypervisor capabilities. So what does it mean? It means that we can support servers such as Xen server, the vSphere, Hyper-V. So these are different servers like the Hyper-V, the Microsoft Hyper-V. And then we have a very low ICA will really require a low bandwidth, right? Which means that it can perform well under high latency or low quality network. So even if the network is not good, the network has a poor quality, ICA can still work in that environment. Okay, so the user experience and functionality capabilities. So when we have the ICA, so the ICA can use your 32 virtual channel to just redirect all the input output operation from data center to the endpoint. So as we said, the endpoint can be another device where you log into the system. Okay, so this when we have now the HDX, which is an enhanced version of ICA, so this will add some performance such as multimedia acceleration. You have high definition graphics, 3D, video performance with strong quality. So those are certain advantages of the HDX, right? So, and then we have the PC over IP, or DOIP. So when we talk about PC over IP, the PC over IP is a protocol that was actually developed in I think 2008, if I'm not mistaken. So it was developed in 2008. What's going on? What's happening here? Okay, so it's a protocol that was developed in 2008. It's basically a high performance remote desktop protocol, which was developed by how do you say that? Teradici. So it later became part of the VMware View, which is now called VMware Horizon, for just delivering all the virtual desktop infrastructure, or VDI. So it's especially suited for high-end graphics workloads such as your CAD. So CAD, those softwares that you use for drawing. Let's say you want to have a building, like it's used for people in construction, in different areas. So to basically do all your design. So your CAD, your 3D modeling, you have video editing, or any type of engineering design or multimedia applications. So this remote desktop protocol is used for those type of scenarios. So it has a strong hardware accelerated protocol. So PCOIP will just integrate with the hardware in terms of encoding, decoding, and graphics rendering. All right, so it's gonna reduce all the loads on CPU resources, okay, and just ensuring a smooth performance there, right? So that's how it works with hardware, and then it's based on what you call it, on UDP. So it's a UDP based high speed transmission, right? So it's a UDP based high speed transmission, which means that it uses UDP instead of TCP. The benefits of that is that we're going to have a lower latency and faster response, right? Okay, and then we have, and then we need to note that PCOIP does not support redirection of peripheral, okay, which means that some thin clients will just had support through custom plugins. So if we have something like a USB redirection, it can be available, but may require a few policy tuning, right, for compatibility. So there is a few things that you need to change. So some of the thin clients from different vendors will provide that redirection through certain plugins, like custom plugins. So basically, that's how we can have a peripheral support. Okay, so all right, so it's and then another common desktop protocol is called SPICE. SPICE is basically your simple protocol for independent computing environment. So that's what SPICE is. So this is another virtual desktop protocol which was developed by Qumranet, right? Later it was just purchased by Red Hat. Will provide it as an open protocol. So after years of community development, SPICE is maturing. So SPICE is another open source remote desktop protocol, which will use certain virtual environment. Like you can use it with like certain environments such as KVM. So this is the kernel-based virtual machine, or Red Hat Enterprise Virtualization, or RHEV. So those are certain system that you can use, certain environment that you can use with SPICE. So SPICE is good for virtual video services. So anything that has to do with video. So as we said here, that SPICE is mature. That means SPICE is now mature. So it's community-driven solution trusted by multiple virtualization vendors. So there's many companies that are really trusting this protocol now. It's very strong for multimedia performance. So if you are using it in certain environments where you have to deal with video editing or anything that has to do with multimedia, so it's really good because it comes with a video encoding integrated, right? So it's integrated with KVM, which is the kernel-based virtual machine. The benefit of that is you have a lower overhead for the guest operating system. So whoever is using the system, for the operating system, you don't have a load over the operating system, even when you are dealing with videos and all those things, because sometimes you will hear, if you ask people who edit videos that use softwares for editing videos, they will tell you that it takes so much energy on the computer, like your computer can be freezing because you are using that type of software. All right. So when you're accessing the HTTP, the remote desktop, so you are actually virtual. So this will reduce the overload on your computer. All right, so it's that's one of the advantages of using that. So one of the protocol can be SPICE. So another protocol, we have the RDP and the remote FX. So the RDP is another protocol. The RDP stands for Remote Desktop Protocol. This is created by Microsoft. So this is a Microsoft protocol which is originally based on the Citrix technology. It's mainly used for Windows remote desktop services, but it's also compatible. So we have it compatible for things like Mac OS. So we have a version for Mac OS, for Linux. So for Linux, you have what we call the RDesktop or free RDP. For Mac OS, you have a Microsoft Remote Desktop app. And so basically, you can have it on Windows and Mac OS or Linux. So it's widely used due to its built-in support in Windows operating system. So that's one of the reasons why this is widely used there. Okay, so yes, don't tell me that you can't hear me.
To interrupt, I wanted to ask on the previous slide, does Spice also add on the quality of the video?
I cannot even hear. I don't know if you are the one who's not speaking louder or if it's my sound.
I'm not sure, maybe it's my microphone.
Okay, what you saying?
I'm asking, does the Spice system that you spoke about in
Yeah.
the previous slide, does it add on the quality of the video, since on the end it says it also improves the HD experience?
You say, does it do what?
Does it improve the quality of the video?
Or you
Does it
asking if, or you asking if Spice, if you're using Spice, if it improve the quality of the video?
yes, does it have an effect on the quality?
Yeah, so it can, when we think about it, okay, because it's a protocol that is used, because remember, sometimes you have a bigger, the challenge that you have, but it's also going to depend on the quality that the video had when the video was taken. Because if you are just doing editing videos, remember you are using a different software for editing. But this protocol, this is just a desktop protocol that will help you in terms of using those videos, so it does not have the whole what puts the whole load of your editing process on the local computer. So you're basically using a computer from a distance with that. So when we think of it, Spice protocol can enhance your video quality in situation where, for example, what situation can I give you? Um, Imagine if your, let's say your, okay, let's say you're using Spice, you're dealing with your video, maybe you are live streaming. That's one example, right? Maybe you are dealing with something and then you are live streaming. But because maybe your internet is not that good, if your internet is not good, you can see that the videos lose the quality, right? You see that. So now when you are using Spice from a distance, so in that case, it's going to improve the quality of your video because your bandwidth is limited at that time. But with Spice, this by using this protocol, it's gonna help improve your video because you are video streaming and your internet is not affecting the quality of your video, because now all your data transfer are optimized by Spice. Okay, so now you will have a different experience compared to just doing everything from your computer, which is affected by how low or high your bandwidth is in terms of uh, your video streaming, right? So that's what I can say in that case. Not
Okay,
not
so
yes, not by just you taking a video that was taken with a wrong camera, and then because you are using it virtually, it's suddenly no, it can't just change like that. But it usually work in the terms of maybe video streaming or things like that.
okay, thank you, sir.
All right, all right, guys. So we have the RDP. So the RDP is basically your remote desktop protocol, which I said is a Microsoft protocol, which can also be installed on different operating system as it comes with a support for other Mac OS and your Linux. So RDP, and then we're gonna have the remote FX. So the remote FX is just an enhanced edition of RDP, so which will support all your virtual graphic processing and multi-point touch, and also USB redirection, which means that with this enhanced version of RDP, it's going to focus more on the graphics and multimedia. So it supports, as we said, it supports your vGPU, which means virtual GPU. You have your multi-touch inputs or other user interaction. It's going to enhance as well the USB or other peripheral redirection. So this is also good for videos and 3D rendering. So this will improve the performance of your multimedia as well. So in RDP, we have all applications, execution and computation that will occur on the server. So the client, you as a client, the user will only handle network connectivity, display of the remote user interface, output and input devices. Okay, so in many countries, many vendors or organizations or companies are using the RDP as a protocol to just improve everything. All right. So the next one will be, so now when we look at, this is how you can maybe compare them. So when we have, in terms of the transmission bandwidth, this is how we have, for example, the PCOIP, which is high. The transmission is, the bandwidth, the transmission bandwidth is high, so you need really good quality. And then you have ICA low and RDP, you know. So this is just a table to try and compare in terms of different features that they can have. So looking at the image that we have here, can show you how in a virtual desktop environment using HDP, the process of just displaying 2D graphics will involve kind of a cooperation between operating systems, the display driver, the graphics card, and obviously the thin client, or any other device that can be used. So yeah, so we have a layer of applications to just produce the whole display content, and then the operating system display driver will interact with the graphic card to just generate all the screens, and then you have the screen frame that are captured from other local display, other local display pipelines, and then the frame that we're going to have is encoded, compressed, and also transmitted to other devices. So that's how the remote client can work. So we have our virtual machine there. So for remote display, screen servers are captured using operating system interface. So just to understand how this works is that when you're using HTTP, the whole process of displaying graphics will involve all your operating system, your display card, and different graphic cards there. So the key display technologies of okay, so when we have now this the display technologies, so we have certain technologies. So when we in the HTTP, the Huawei Desktop Protocol, there's a set of advanced image optimization technologies that will be involved just to ensure that we have excellent clarity or uh, an efficient bandwidth, okay, during your 2D graphics display. So we have the lossless, right? Lossless compression for non-natural images. That means that HDP will automatically detect user interface elements such as your text, characters, or maybe icons, okay, and different operating system graphics as well. So these details will be compressed just to preserve the sharp edges, different details, or a high readability when we have whenever the system detects things like these graphics. All right, and then we also have a non-transmission of redundant image data just to save the bandwidth, which means that the transmission of data that are not modified or changed will be limited. So we have a transmission of only changed regions. So instead of sending full screen updates every time, HTTP will track changes of maybe at pixel block. It will change. It will check the changes, and only the modified areas or the modified data will be transmitted. So this will reduce the bandwidth usage, right? And it's also going to improve the responsiveness, especially when you're like scrolling or interacting with the user interface. So instead of, I'll give you an example. When you sometimes even when you're using, let's say you have only 1 gig of data bundles, and you spend time on Instagram, you will realize that you will use more data than being maybe on a different platform. Why is there a difference between a different platform when you're using? It's because of exactly what we're talking about here. Your bandwidth is used based on the type of data that you are uploading and downloading. So when you're talking about this case here in the HTTP, so instead of sending full screen updates every time, like every time you're scrolling or using the system, it sends all this, like you are using the bandwidth. So to save the bandwidth, what it's going to do is only going to track the changes of the pixel blocks, and only the modified data are transmitted, right? So this is how HTTP is going to improve the responsiveness and also save the bandwidth. Okay, so it also supports a multiple image compression algorithm, which means that different content type will use different algorithm. So, for example, you're dealing with text or icon, you have a lossless encoding, which will help you have clear visuals. Or if you have photos, videos, it's going to use a higher ratio compression. Yeah. So HTTP will just select the most suitable compression in real time, just according to the scenario, based on what you are trying to do. So one of the advantages with that is that it's going to reduce the CPU load with intelligence encoding decisions that it's taking there. All right. It also improved the user experience, even if you are on a low bandwidth network. Even if network is that good, but it's going to improve your experience with the system because of the system, yeah, depending on what you are accessing. Right. So there's also other advantages when it comes to audio technologies. So the HTTP server will just simulate an audio driver on the virtual machine. So the audio driver will interact with the Windows audio system or audio engine. So this will basically give us access to a technology that is going to improve the audio. So the audio virtualization in HDP will basically help in terms of supporting real-time audio in cloud desktop. So HDP will implement a virtual audio driver on the server side of the virtual machine. So this driver will interact directly with Windows audio system, which will enable all the audio playback recording through the thin client. So how does it work? So you have, number one, you have your application or the operating system, which will generate the audio, and the Windows audio engine or Windows audio subsystem will pass the audio to the HDP virtual audio driver, and then the data is compressed and transmitted over the HTTP channel, and then the thin client will decode the stream and output the sound to the local speakers, or will ensure that you have a synchronized high quality audio experience. So that's how it's going to work. So in terms of this, if you want to, let's say, if you want to record, in terms of recording, what will happen is that the thin client will capture the microphone input, and then the data is compressed, right? So the data, in this case, the data will be compressed and sent to the server. So the data is compressed and sent to the server, and the HTTP server will just decode it, and then the audio driver will inject into the Windows system so that it can be used by the application. So the system HTTP will support real-time communication and collaboration scenarios as well in terms of audio. For example, if you are using Teams or Zoom, right, on a Zoom call, on a team call, so that will improve. So when you are using a virtual computer, like one of the advantages is you can easily have good quality of these online meetings, because it improves the quality of your audio or the quality of your videos. So that's one of the advantages of using the system. Okay, so we have a very high high fidelity music compression. So with HTTP, right? So HTTP will really apply kind of a collection of advanced audio optimization technology to also ensure that we have a clear or real-time audio environment. So we have a high fidelity compression. We have a high fidelity compression algorithm that works there. So HTTP will automatically detect audio scenarios. So let's say, for example, the scenario is that you have a human voice. Maybe that comes over a video conferencing, right? You are on Zoom or something like that. Right? So if you're on Zoom, or so basically HTTP will automatically identify the scenario. You are on a Zoom call. And then what it's going to do, it's going to use type of compression. So in this case, it's going to use a voice optimized codec. And then it detects another set of just music playback. It's going to use a different. So what will kind of happen is that HTTP will always select the best codec for the content being played. So, and then we have an intelligent automatic denoising, right? So this will help in terms of reducing, taking out background noise on that, and that. So the active noise suppression for voice over the internet. So this will remove your background noise, like the winds or like typing or any environment noise, right? So this feature will just ensure a clean audio, even if you are currently in a noisy office environment. All right. So another feature of this is we're going to have a low latency in terms of the way the voice is transmitted. So we have a low latency transmission. So transparent voice transmission on the thin client side to just avoid buffering. So gonna avoid audio buffering delays, kind of prioritizing all the virtual channel for audio packets. So this is really critical for real-time calls like your Teams, Zoom, or any other system like that. So, and then we also have a high sound quality, So the default quality of the sound here will be a 44 kilohertz sampling rate. Okay, so this is the CD level audio. So that will provide a clearer sound for all your multimedia playback. So this is better for entertainment, and you have a good experience when it comes to your sound. It also supports the stereo mixing. All your virtual machine audio input and output can be mixed. So basically, you can combine multiple audio streams on the virtual machine. You have your system sounds, app outputs, or voice input sources. So this will just ensure there's a complete synchronized audio output to the user. Okay, so using this. So the key technologies, audio technologies that is provided by HDP, detection, where we are in, and then it's which object to use to give us the best quality of voice or sound or music. You have the feature of noise reduction, which will clear the communication anywhere, wherever you are. You have a low latency, which means we have a stable real-time conferencing that we can have. We have a high sample rate. That means we have full fidelity sound, stereo mixing. So those are advantages of using HDP when it comes to audio. But we've spoken about images, audio, there's also video. So currently, Huawei Desktop Protocol supports two types of video playback. So we have video recording and video redirection. So those are the two video playback type of video playback that we're having. So those mechanisms that we have will help us in terms of delivering video in virtual desktop. So your video recording, so it's basically the server side decoding plus re-encoding. So how does it work? Is that you have your the video will be decoded, right? So the video will be decoded on the server, and then it's gonna be encoded. It's gonna be re-encoded by the display protocol. So the display protocol is gonna re-encode the video, and then it's gonna be transmitted to the transmitted to the thin clients. And then the client only display the final image frame. So the advantage of that is that it works in with any media player, and any video format. But the disadvantage is that it can have a very high CPU consumption on the server, because you have your encoding loads that will increase when video will like refresh, so it also reduce your virtual machine density per servers as well. So because happen because every time the system will require constant detection of video region to see which part of the video has changed. So that will really make the whole system drag a bit, right? And then we have the other mechanism, which is the video redirection. So with video redirection, the video streams on the server are captured and transmitted directly to the client for decoding and display. So with video redirection, so this is the client side decoding. That means that the server will intercept only the compressed video stream. It's gonna detect only the compressed video stream, and then the thin client will decode and render the video locally. So one of the advantages is we have the minimal CPU usage for the server, but another disadvantage can be that the redirection will depend on the supported players. Okay, so if the players being used for this media is supported by HTTP. So that will be one of the things that will affect everything, right? So HTTP will support 4K video playback, all right? So HTTP will provide this high resolution 4K video playback for virtual desktop that will ensure that we have a smooth multimedia experience. So how the 4K playback works is that the server-side streaming, so we have source video files that are transmitted from the server to the thin client. All right, so the source video files are transmitted from the server to the thin client, and then on the client side, there's a process. The process on the client side is that the video is decapsulated and decoded locally. All right, and then we have the audio and video streams that are played back directly on the client. All right, so that's that will be all for today in terms of the first session. But before we close that, we also we also have the certain an advanced video optimization technology which is used by HTTP just to ensure the use of the system resources in terms of how much of the system resource is being used because of videos. So in terms of your CPU, remember, you don't need a lot of pressure on your CPU when you're dealing with that. So HTTP as a mechanism, like an intelligent identification of the way the video is being used. So that means the display server automatically distinguish between video data, example, your movies, animation, or your standard GDI, which is your graphics device interfaces. For example, your text, icon, and user interface elements. So the display server will distinguish between that, because remember, you have your user interfaces, your icons, those are permanent things that are there. But then you have your video data, such as movies and other animation. So it's going to distinguish between that so that it knows how it's going to allocate the resources. So you have, for example, when you're dealing with video streams, so video streams are encoded using the H.264 or the MPEG2, right? And then the thin client can handle decoding locally, which is going to reduce the server load. All right, so you also have a dynamic frame rate, which means that playback frame rate will adjust in real time according to the network condition, which will ensure that we have a smooth video playback even under low bandwidth. And then you have your video data auto addition, which means that video streams automatically resize based on the display resolution, the playback window size. This will reduce all the CPU usage and ensure that we have a good experience even when we're dealing with videos. And then we have the multimedia redirection. HTTP will optimize the videos, you know, the video softwares or the videos, the softwares that are used in terms of in terms of the video players, right? So we're going to have an application sensitivity. So HTTP optimized commonly used software such as video players, your image processing tools such as your Photoshops and all those things. So optimization is based on the customer requirements, you know, for better performance or better responsiveness or the display quality. So this is also one of the options that that you will have there. All right, guys. So that's it for this first session of the day, and then I will see you in 15 minutes for the second session with HCIP AI.